Welcome back. This is episode 5 of the Struck podcast. I'm your co-host, Dan Blewett, and I'm joined here remotely by lightning protection expert Alan Hall. Alan, how are you?
Great, Dan. How are you doing?
I'm doing well. Here on the Struck podcast, we talk about everything lightning, aviation, and just current news in the aerospace field. So, Alan, what is going on today in aviation? What do you got? Any news for us?
Well, everything is not flying. That's the news today.
So planes are just buses. So Airbuses are just literal buses right now.
They're literal buses, or they're cargo airplanes. I've seen a lot of conversions happening to making passenger airplanes into cargo airplanes, which is the thing to do. I saw FedEx is really busy. I think it was a New York Times article talking about how busy FedEx is, and we're on pretty much every FedEx aircraft with our strike tape product, and we have seen them flying a lot, because everybody's ordering things off of Amazon, and
Yep.
FedEx is one way to do that, or it was until recently. FedEx and Amazon had a parting of the ways there, but there's still a lot of things being mailed around because everybody's stuck at home. So there's a lot of cargo business going on, and that at least keeping some portion of the airplanes flying, which is beneficial.
Yeah, and my apartment building here in DC, they've and God bless all the people that are doing a lot of these tasks. Like, we have a concierge desk, and then you have to go get your packages from them, and they're there 24/7, which is nice compared to some buildings. But
yeah,
they said, like, hey, please come down and get your packages quick when they come, because we have way more packages than even like the typical Christmas season.
Whoa.
So when you're, I'm in a pretty good sized building, and when you consider, just like people are trying to order literally everything and not leave their house, which is good for the pandemic, but it's not great for the people who have to handle all these packages. And,
right.
We have to come down and sign for them. Like, that's fine for me. I interact with one person one time, but they're interacting with everyone in the building every day.
Yeah.
And so all of us have just been obviously trying to abide by whatever rules they set and give them their distance and, take their package and be about our way. But, there's a lot of people doing those jobs, whether it's your postal worker, your package delivery man or woman, all these things, grocery workers, like there's a lot of essential jobs that are just, I appreciate everyone continuing to do those. It's putting them at risk, and they're doing just to kind of keep everything going.
Yeah. Well, I know here we got until there's a little bit of a tussle in a local town where the post office stopped delivering to a particular apartment complex because it had possibility of coronavirus from one of the dwellers there, and so they stopped delivering to that place because the postal workers were really concerned about just the interactions with the people there, and even just handling packages. So you can kind of see that. I'm not sure how that all played out. I know that there's been some news articles about it, but you can see both sides of it though, because obviously there are people in the apartment complex which have been fine. They've been sequestered for 4 weeks now and are clearly not at risk. But as a postal worker, you're never really sure. Yeah, you don't know. You run across hundreds of people a day, I'm sure. Yeah,
especially if you're older, and you can say, "No, I'm not going there. Like, I don't want to die." Like, it's a reasonable stance to take. So, it's hard. And I was listening to another podcast this week, and it was by this entrepreneur, and his co-host is also like big in tech, and he was like, you know what though? He's like, I haven't opened a piece of my mail in, he said, in 10 years. He said in 10 years. I'm like, what?
10 years?
And he got questioned by his co-host, and he's like, yeah. He's like, I just don't have important mail. He's like, the physical mail that I get, and it's been this way, he said, for a long time, it just doesn't have any value to me. He's like, I'm in business. Like, things that are valuable are DocuSign, they're electronic, they're email, they're message. He's like, I just haven't gotten important mail in a really long time, unless he was not including packages, obviously.
Okay. You're talking about paper mail letters.
Yeah, paper mail that fits in your mailbox. He's like, I just don't get, like, he's like, the postal service right now, he said to me, he's like, if they don't want to deliver to my house, that's okay. He's like, I'm fine with that. It's not essential to me. Packages, separate issue, but I thought that was
this
an
is like
take,
that Seinfeld episode, right? Wasn't it Seinfeld where Kramer decided he didn't want to have any mail anymore? It was too much to deal with, and he told the post office not to deliver. Wasn't that Seinfeld?
I don't remember it, but that sounds like.
Newman's the postman. He's telling, no, you have to take the mail. You have to take the mail. And Kramer eventually puts bricks into his mailbox so they couldn't deliver the mail, and it became a big tussle back and forth. That sounds very similar to that. Yeah.
Oh, with Kramer or with wait, you just said his
Newman.
name? Newman.
Yeah,
That sounds like a golden episode. I gotta look that up.
that's a golden. Yeah, how appropriate that Seinfeld applies directly to life. Yeah, it
I
does
can
a
see
lot.
I can just picture those two bickering. You gotta take the mail. I don't want the mail. I don't want the mail. Yeah,
But
that's
you can write for that show. It's exactly that's exactly how it went. Actually,
yeah.
yeah,
I can picture it. I can picture it. So today we're talking about parts manufacturers a little bit, and we're going to talk about
yeah,
paint, which we've covered both of those in just like on the surface
yeah.
in previous episodes. But so one company that does some pretty interesting stuff out of Israel is Kanfit. I was on their website a bunch the other day doing a lot of research for the show, and
Yeah.
it seems like they have a unique niche where they can make really high quality metal parts. They can also make really
Yes.
high quality composite parts.
Yes,
But
they
they can
do.
also, it seems like their specialty is that they can also make really high quality metal and composite parts. Whereas for other, I guess, suppliers, you might have to go to a composites person and a metal person and kind of combine them, like
That's true.
pass them together. But they can kind of
True.
do it all in house
Yeah.
and get a unique part. So tell us a little more about Canfit.
Well, Kanfit is based in Israel, and I forget how long they've been around, but they're a well-established company, and they're involved in a variety of different aerospace markets, from making parts for aircraft to making drones. They make radomes, so they're involved in a lot of different areas. But it's one of those unique businesses and places where they have basically skilled aerospace workers that can do the gamut, and that's unique today. I'll give you the example in the United States. In the United States, it tends to be either you make composite parts because you're hip and cool, or you make metal parts because it makes money. And so rarely do the two shall meet. So it's a different skill set. Clearly, it's a different skill set. So you have to have a pretty highly educated workforce to do that. Composite parts take a lot of you have layers of material you're putting on. You're dealing with epoxies or resin systems. It's complicated. You may have you have an autoclave in there. So you're checking temperatures and that kind of stuff. The metal work, I think, is just as important, though. Even though just because we've done it for a number of years now, making metal parts has gotten easier in a sense, but they're no less critical. So having a company that can actually make both ends of that is, in today's world, really unique. And I don't know if it's just a fact that they're in a smaller country and they just need to be very versatile, and that's what drives it. It also could drive it just because they have the skilled labor force to go ahead and do that. But we've been working with them for a number of years, and the things we see come from there are exceptional. They really are.
So you look at some of the. So I was listening to a Jeff Bezos interview just sometime last week, and he had a really insightful thing to say. He was talking about his company Blue Origin, and in the context of Elon Musk's company SpaceX, and
SpaceX,
he was and this was a talk from I think 2018, but he was explaining why he's putting his money into that, and he basically said that when Amazon started, he was able to start that company with $1 million in his garage because there was already this massive infrastructure already existing for him to tap into, which was FedEx and UPS.
Yeah.
All these, the internet was still young, but the internet existed.
Yep.
And so he basically said, like, I had this huge backbone with which I could just sort of hoist my company and become this big company.
Right.
He said, but with space, he said, no one, and he used other companies as reference. He's like, no one's making an iPhone in their garage. He's like, the technology, like, you just can't do that. It requires too many people who are highly skilled to make a product like that.
Yeah.
He said that,
Sure.
and he said the same thing he's like, no one is going to space or making improvements on us going into space from the garage. So he said, I find that it's my contribution to start to lay some of that groundwork and make that foundation in space travel, where maybe in X amount of years, 20, 30 years, someone can take a small company using what we've started and then grow into a big company that really furthers the human race and our space exploration. So I thought that was really interesting, and I was thinking about that as I was looking at some of Canfit's manufacturing, and as you look at some of these parts and some of these aerospace initiatives and endeavors. And I was thinking to myself, like, man, this is really technical work. And looking at all
Yeah, it is.
their manufacturing and like
Yeah.
all the research and development, I'm like, how could a
Yep.
person try to get into like aerospace or parts manufacturing? It seems like it's a really high cost to just be like, hey, I've been an engineer my whole career.
Mm.
I want to start my own,
Yeah.
parts, my composite. It seems like there's
Yeah.
still a lot of big barriers. I mean, can you speak to that? I mean, how do some of these
Oh, yeah.
huge airline companies get going?
You need a lot of cash, and you need to have a customer that's willing to work with you as you put this thing together. Right? Virgin Airways was another example. There's been a lot of like airlines and aerospace companies. Sierra Nevada Corporation is another one that comes to mind. So there's a bunch of companies that have kind of quasi garage built out, but it's hard because you just always need more and more cash to get to the next project.
Mm-hmm.
And in a sense, it's almost to the point. Well, if you think about so my wife and I were talking about this the other day about how few aerospace companies there are today, even from when we first joined. When we first joined, we were working for General Electric, and General Electric had an aerospace division. Well, they don't have an aerospace, and they sold it to, at the time, Lockheed, who then merged with Martin, so it became Lockheed Martin, and that was in a realm of about 3 years that all that happened. And the consolidation, because all the projects, we were working on spacecraft projects at the time, those spacecraft projects cost so much money, and if you had a bad launch or you didn't get into orbit, it's so much money. You couldn't, as a small organization, you couldn't really afford it to go wrong. Jeff Bezos, Elon Musk, those kinds of financial wherewithal, Bill Gates, Paul Allen, those kinds of people can afford the risk and could lose the money and still go out to dinner at night.
Yeah,
there's a difference, right? And it's so, if you think about I know they're just celebrating the 50th anniversary of it's a celebration, I suppose, of the Apollo 13 launch and the problems they had on Apollo 13. And if you kind of thumb through some of that information, like, wow, that's really rudimentary compared to if we were building the same exact thing today, and we are trying to build basically similar things today. We're spending so much more money on it, and it's so much more complicated than some of the stuff we were building way back then, but it's also a lot safer, which is the point, right? So even though the process is the same, we have added a lot more capabilities, like the SpaceX launches where they're landing vertically, right? They'll be able to reuse a lot of the equipment, and which was an overall cost savings, but the complexity and the risk involved with that, because that could have not worked. And if it didn't work, well, Elon Musk is at risk, but he's not at that much risk, in a sense, because of all the money he has. So so if the rocket, and it did, right? If you remember some of the early rocket launch landings, where it would just tip over, or they're trying to let it out on that barge out in the ocean, and it wouldn't quite do it, or it was too windy, or all the things that play into that. You need big companies with ability to swallow it, and even Boeing has really struggled in some of these launch things lately, because the PR-wise, in a publicly traded company, it's hard to have big mishaps, right? And so I do see that sort of the Bezos thing makes sense in the sense that if one of his little experiments goes wrong, okay, it's on him.
Yeah. Well, as you start to wade through what Kanfit says, that they are one of the very few people that can make really good quality composite and metal parts.
Yeah, true.
You can probably see why. Like if you're you're in the metal part industry and that's your niche, and you say, okay, we want to get into composites, there's probably just a really big startup cost to then get all that tooling and technology and all that stuff.
It's
and
expensive.
Then to have people that know how to do it, and you got to find. I mean, it seems like that's why everyone starts to get into their little niches and
everybody on the who's actually working in the factory there has expertise, and it's hard to find people who have both expertise in sort of metal and on the composite side, and on the engineering side. You hear it's the Beech Starship black aluminum airplane thing that happens where we make a decision that everything's going to be made out of composite or it's going to be made out of metal, The reality of the situation is the best solution is a combination of the two, which is where Kanfit is. That you can make metal parts because they're just lighter. They can be lighter than carbon fiber is heavy, right? But carbon fiber you can orient where the strength is in a piece of composite. In a piece of metal, you can't really do that. So every part, and depending on what the structural loads are and what you're using it for, a design decision needs to be made whether it should be made out of metal or should be made out of composite. In a place like Kanfit, you can make those decisions all the time because you can do both, right? So you probably have the best overall solution when you put all these pieces together. You probably have the best product overall because you made those trade-offs. You didn't have to do one or the other from the start. You can make the best decision for the part, for the assembly, for the whole aircraft up front, which is going to lead to a better end product.
Yeah, that makes sense. So let's shift gears. I want to talk a little bit about, we talked about expanded metal mesh last week. So there's another company, Niles Expanded Metals. They're a big player in the industry with their micro mesh LSP. So what are some of the applications of metal foil?
Boy, in the aerospace industry, it's all over right now because so many parts are made out of either fiberglass or carbon fiber or a mixture of the two, and everything needs lightning protection for the most part. And the choice that has been developed over the years is expanded metal foils, just because they're relatively easy to install. They add a lot of conductivity into a part. They also are readily fixable. It's a simple material to use. It can be bonded on secondarily. It can be bonded on with the primary part, so it can be integral. So there's a lot of benefits to expanded metal foils, and we have oodles and oodles and oodles of data from expanded metal foils from lightning protection standpoint. So there's book data out there on it, which helps designers choose an expanded metal. So the obviously in wind turbines, it's a little bit different. It's not typically used on the exterior of a wind turbine, but it's tended to be used on the interior, especially where there's carbon fiber spars. So they want to keep energy out of the carbon fiber. And so they use expanded metal foils to do that. So that a lot of the energy stays in the expanded metal foil and out of the carbon fiber structure. So they're truly two different applications, but both are just very important for both markets. And the thing about the expanded metal foil market in the aerospace side is really the quality of the product, the consistency of the product, right? Some of your worst nightmares if the material comes in kinked and it doesn't lay flat, so you can actually see it on the aircraft surface because it's not laying right. Or if it's got some wide variability in its resistance range, because the resistance has a lot to do with this lightning strike protection. So if you've, and goodness knows why I've got wrapped into this one time, but we were actually measuring different lots, the resistance of expanded metal foils from different lots, and I was surprised how much variability there was in it. But that had to do a lot with the manufacturing, the place that was manufacturing it, quite honestly. So in a place like Niles, which if you go on the website or actually look at some of the YouTube videos from them, it's a very automated process, and they seem to have very consistent products. And they also offer a variety of different materials you can choose from. It's right on their website. So the two big ones in aerospace today are copper, which tend to be used a lot with carbon fiber, and aluminum, which used a lot because it's lighter. Aluminum gets used with fiberglass. Aluminum and carbon.
Are these laid on top, or are they embedded within?
Well, they're laid on top. So think of it as another structural. Think of it as a ply. So it's usually, if you're building up a composite part, it's usually the foils tend to be the first ply down, and then you start stacking your carbon fiber plies on top of it. That's generally how it goes. So it's actually built in when they put the part in the autoclave and they cook it off. The foil is actually built into the exterior surface of the part. So it's the outermost layer of the part. Think of it that way.
Gotcha. Okay.
Yeah. So from a handling standpoint, and the expanded metal is beautiful because it'll go to crazy contours and not kink, or you can kind of lay it out where it's flat. A solid sheet wouldn't do that. So having the holes in it allows the epoxy resin to fill it up and to grab hold of it and bond it on, but also lets it lay flat, which is really important if you're going over some, like a fairing, like a belly fairing on an airplane tends to be very funky curvatures for aerodynamic reasons. Yeah, a lot of parts like that where you want to have curvatures. The expanded metal foils fit that niche where you can lay it down. It's pretty thin. You can kind of massage it onto a part. And when it's done, it still looks good. Yeah. And then, the difference between the copper and aluminum. Aluminum is galvanically incompatible with carbon fiber. So if you put aluminum on carbon fiber structure and you expose it to salt water, like typically happens, the aluminum just gets eaten up by the carbon fiber. Aluminum just turns to powder. That's what it looks like. So copper is the choice with carbon fiber, and then obviously aluminum then gets used a lot of times with fiberglass. But Niles offers both of those things, and in different variations, different thicknesses, different essentially resistivities, and you can actually punch in numbers on their website and get kind of anything you want out of it. There are some very common weights. And if you look around different aircraft programs, they're kind of dialed in, and that's based on the lightning testing. So if you can go on different websites and check out some of the generic lightning testing that has been done, you can get a sense of the thickness of the foil. It's usually by weight. 0.022 pounds per square foot is a very typical copper foil that's used on a lot of different aircraft, or around there, 0.020, 0.022, 0.024. Aluminum, not so. I don't see that as much because we're not making a lot of fiberglass parts today. But the copper tends to be roughly that way, so you'll see that on Niles' website.
Gotcha. And these are all going to end up being painted parts, because I want to segment to some of the stuff Hondajet's doing. So what is Hondajet doing that's different than other companies as far as paint and their controls and their quality with painting their aircraft?
So the Hondajet is a carbon fiber fuselage empennage aircraft. The wing is metallic, and on the fuselage they're using expanded metal foil. I believe it's copper. I worked on that program, but I believe it's copper. And so when you have smaller private jets, so sort of Part 23 light jets, I'll call them, the composite structure is not thick. It's not like a 787 where it's a quarter-inch thick. It's much thinner than that. So the lightning protection is really critical. And in the Hondajet case, where they're using an expanded metal foil, one of the critical factors is how much paint you apply on top of that foil. So part of the lightning qualification process is to go off and to test that carbon fiber part with the copper foil with a certain amount of paint on it. You always use a worst case paint, because as you get thicker in paint, the expanded metal foil becomes less effective and you start to have punctures or damage into the carbon fiber structure. So in the Honda case, it's a very aerodynamic aircraft. It's a very advanced aircraft, and they did a lot of honing on reducing weight in that aircraft to make it efficient. And it's one of the most efficient light jets on the market, and maybe the most efficient light jet on the market right now. And so they're having a lot of sales because it just doesn't have the fuel burn that other aircraft do. And so part of that deal is that you have to be able to control the paint thickness. Now, Hondajet early on, and a lot of aircraft companies started out by just having painters, hand guys in masks and the whole thing with sprayers, spray paint on it, and try to keep it within that certain thickness range. So typically, an aircraft specs will say that the paint thickness is somewhere around 5 mils thick, so 5/1000ths of an inch thick is where the paint is. But that's hard to do on a large object, particularly if there's contours on it. So the paint thickness varies a good bit. And I've worked on programs like that, in composite programs where the paint thickness was, plus or minus 3-4 mils. It depends. Mostly plus, very little on the minus side. It's like +4, -1. So in the case of Honda, and they're having so much expertise on building of cars and painting of cars for that matter, and have done it for a number of years, they have used robots to do it. And so they decided to take the technology from the automotive sector, which they are great at, and apply some of that knowledge into the aircraft market. And they started painting their aircraft with robots. And it was brilliant. And there's a YouTube video of it now, and you can just go watch this process happen. But essentially putting on the the white top coat paint, which is usually the problem child, is that white top coat trying to control its paint thickness. Well, they can get very, very consistent paint thicknesses because they're doing it automatically, which is brilliant, right? So not only can they have a very lightweight structure and they're using a very advanced expanded metal foil for lightning protection, but they can also do the other thing, which is to control the paint thickness coming out of the factory. That's genius, right? And that's where a lot of other aircraft programs have struggled, quite honestly, is controlling paint thickness, because as employees come in and out, and as techniques change, and one guy does it one way and another painter paints it the other way, you get wide variations, and it just adds a lot of labor and time and cost into the product. Well, Honda has just eliminated that. They eliminated all the variability, and they've done it robotically. That is absolute genius, and the aerospace industry should have done it years and years ago. The military has done it on some of their applications. The U.S. military has done it on some applications. I believe some of the European forces have done something similar, but you don't really see it in the commercial market. Honda's done it, and it's amazing to watch. You should go watch that YouTube video because it's amazing to see that go on.
Yeah, and we'll put that in the show notes as well.
Great.
But I mean, I think the audio industry's been robotically painting cars. At least some manufacturers are, I'm sure.
Yep.
Like I've seen videos of, like, I know it was Audi. They were just showing how much automation there was start to finish. Just the entire chassis getting picked up by two robots, dipped, and whether it's galvanized or whatever the process was, and then coming out. And I think they're actually dip painting a lot of their, if not the whole thing. But it seemed like those processes, which makes sense, especially on that scale. Yeah. Now I know with like a Boeing 787 or something, they're not going to produce 40,000 of them. So maybe
I don't know.
They're like, well,
not in a year,
hand paint them, but
well, because there's a lot of real estate there too, and the issue and I think for Honda is they've been very specific about the variations in the paint scheme. You can get it different colors, but the paint scheme is essentially the same. The stripes, which tend to be where everybody puts their mark on their particular aircraft. On automobiles, you don't do that, right? So they come red, yellow, blue, right? They're one color, and any kind of variation is something that's done secondarily. It's not done at the factory typically, right? And so that makes it easy from the automation standpoint. And Honda did that on the aircraft, right? They just said, "Hey, here's the breadth of colors you can choose from. Pick one." And I always think, well, obviously Honda knows consumer tastes in automotive side, so they just, especially on the sports car side, so they applied that knowledge directly to their aircraft too. So I always thought their color choices were very, very wise, because it fed into a certain demographic, and it was cool looking, and they still are cool looking.
I mean, cool always sells. It doesn't matter how old you get. It's like, I want the cool looking airplane. No, I want the airplane that looks like,
like a DC-3.
Like the equivalent of like the white nurse's shoes. It's like, no, you want the Italian loafers of the airplane.
Yeah, and well, Honda has done that, because if you look at the design of it, right, where they've on the Hondajet, where they've taken the engines off of the fuselage and mounted them to the back of the wing, essentially. It's a slick looking airplane. It's very slippery, right? They've done a lot of work on the aerodynamics. They spent a lot of time, many years, working on the aerodynamics of that aircraft. And it just looks cool on the ramp, and having been inside of it and been around it quite a bit, it's a cool looking airplane. I can't say all new jets look like that, but they've definitely did some homework on just the sort of street appeal of that aircraft. It looks cool. It does look cool. It looks really cool in flight.
Well, and especially for someone who's got, very deep pockets, who could afford a private jet. Yeah. They're going to be like, "Oh, what's that one? I want that." And just throw down their credit card, like, whatever they cost.
Well,
40,
and
50,
Honda comes with a reputation, right? So Honda has the quality reputation. I can't remember the last time I bought a non-Honda car. It's probably been 20 plus years since I bought a non-Honda car. And the reason I do it is because it's so dang reliable. And it has some of the features that I'm looking for, but most importantly, it's never, and we've owned a couple of Hondas over this 20-year period, we've never had a Honda break down on us on the road, not once. And so that builds brand loyalty, right? And I think the same thing's going to exist for this other aircraft company, is that as this aircraft shows how durable it is, and it has some really great performance features, it's just going to create a bigger marketplace for it. Absolutely.
Yeah, I could definitely see that. And so before we wrap up here, there's one other thing I want to discuss, which is there's been some paint peeling issues on the Boeing 787.
Yeah.
And some implications with fall arrest protection systems. So tell us a little bit about that.
So the FAA put out a safety notice essentially about a week ago. On the 787, when you're working on top of the wing, they have these suction cups, and they have on a lot of different aircraft. It's not specific to the 787, but you have these essentially suction cup devices. You suction cup onto the wing, you clip into it, so you're harnessed in. So if you slipped, it would catch you, and you wouldn't fall to the ground because the wing's pretty high. You would get hurt if you fell off that wing. So they had this suction cup device that they were grabbing onto and latching their harnessing into, and the suction cup devices were pulling the paint off the wing skin, right? So the arrest, the fall prevention device isn't sticking to the wing, and I'm sure it raised a lot of eyebrows. Like, why is the paint coming off this relatively new airplane? What's up with that, right? And the safety bulletin goes on to note that they did some research into it, looking at what was causing the paint to lift off, and they realized that there's some level of UV degradation between the primer system and the composite structure. So the composite structure comes out of the tool, and it's carbon fiber, and it's got resin system on it. Typically, they kind of scuff that up a little bit, and then they'll apply a primer onto it, and that primer bonds onto that resin-rich surface. Then you start putting layers of paint on it, and you get to the top coat, and that sticks on last, right? So they had some sort of UV degradation going on, which decreased the adhesion of the primer to the composite skin. Well, heck, that's really hard to pick up once the airplane's painted. It'd be very hard to notice where that was. So you're going to have to find out the hard way until the aircraft gets repainted. And one of my colleagues saw that notice and commented, how did they get that much UV damage on the wing skin unless it was just happened to be just sitting out in the sunshine for quite a while and it didn't get properly prepared before they put primer on? Or there's just some weird UV thing where as the aircraft is primed, and a lot of times they sit out on the ramp primed, was the UV light affecting the primer to the composite structure while it sat outside waiting to get top coat on it? That's a good question. It didn't really say that in the safety briefing, but all these things revolve around, at one point or another, revolve around lightning protection, right? So if you have a composite structure in a wing with fuel in it, like 787 does, there's lightning protection in there. Is there something about the lightning protection system that's affecting that also? That's the question mark. And in my head is like, ooh, I wonder if it's something about the way the lightning protection system on that aircraft is affecting the paint adhesion. But it's something to watch out for. And I know everybody that makes a composite structure right now, particularly a wing, is, I'm sure, thinking about, do we have the same issue that Boeing does, like in the A350 or A380? Do we have a similar issue? Don't know, but the industry's going to go look.
Yeah. Well, if they hadn't figured this out from the suction cups, would the paint have started peeling like during flight? Like what were the implications? It seems like they're just saying stop putting the suction cups on them.
Yeah.
But otherwise, it's probably okay. Is what it sounds
well,
like?
there's all different levels of adhesion, right? It's like different levels of masking tape, so you can get cheap Scotch tape, you can get to masking tape, and then you get to what we call in the States duct tape, or the brand name where everybody's right now is Gorilla Tape, right? All the commercials are Gorilla Tape, which is super sticky. It is. Paint's just like that. Some of it sticks lightly, some of it sticks moderately well, some of it really sticks, and it's impossible to get off, right? So I haven't seen photographs of 787s with paint issues on the wing. Doesn't mean they don't exist, but I do look around there's a lot of photos taken of airplanes, obviously, so you would show up pretty easily. I think somebody would notice it. So it must be the paint adheres enough that it's sticking in flight, but if you put suction cups on it,
you can't scale it. Yeah.
Yeah, you put suction cups on it, you put a 300-pound person on it and pull, it may not stick. Yeah.
Gotcha. Well, and especially if you're, say, sliding off the plane and then it catches, that's way more than 300 pounds of force. That's probably a couple thousand pounds of force just being shocked.
Impulse
right
force,
cup.
Yeah.
So
and it's just pulling right on it. Yeah.
Yeah, so that makes sense. Well, That's it for today. Alan, great show. Appreciate you.
Yeah, thanks, Dan.
Covered a wide range of topics today. And if you're new to the show, always check back. We are on iTunes. We're on Spotify. We are on YouTube. And if you're looking for short clips with that are just topical, so you want to learn just about paint, or you want to learn just about different types of lightning protection or metal bar
Expanded
diverters.
foils?
Yeah, you just want to get a quick hit about metal foils. Check out our YouTube channel because we have lots of little clips that can help you just get your quick knowledge burst and be on your way. Lastly, subscribe and share with a friend, and we'll catch you back here next week on the Struck Podcast.